Hello everyone. Today we are going to talk about a classic puzzle known as the Tower of Hanoi. It's a simple yet intricate problem that's been studying over 150 years and holds significance in mathematics, computer science, and problem solving. The Tower of Hanoi is a puzzle that consists of three rods and a number of discs of different sizes. The objective is to move all the discs from one rod to another, following three main rules. Only one disc can be moved at a time. Each move consists of taking the top disk from one stack and placing it on top of another rod. No disk may be replaced on the top of a smaller disk. It sounds simple, but it's a puzzle that quickly becomes complex as the number of disks increases. The Tower of Hanoi has the deep connections to recursive algorithm and exponential growth. The number of moves required to solve the puzzle with n disks gets the formula of m of n minus 1 is equal to 2 power n minus 1. So for just 3 disks you need 7 moves, and for 4 disks you need 15 moves, and for 64 disks 1 quintillion 844 quadrillion 674 trillion 407 billion 370 million 955,161. This exponential growth illustrates how quickly problems can be computationally intensive. The solution to the puzzle can be broken down into a recursive process. Here's how. Move the top of n-1 disks from the source rod to an auxiliary rod. Move the nth disk, the largest disk, directly to the destination rod. Move the n-1 disk from auxiliary rod to the destination rod. The Tower of Hanoi has several applications, particularly in recursion, algorithm analysis, and data structures. Here's a couple of ways it's used: recursion practice and memory allocation. Recursion practice is a great example for understanding how recursion works. The solution can be written as the recursive function, where the function calls itself with the smaller subproblem. Memory allocation. The process of moving disks between rods is analogous to managing memory or data in computing systems, where we need to organize and transfer data efficiently. Here, there's a function of program for the Tower of Hanoi. Here's a brief explanation to the Tower of Hanoi function. In this program, the void return type with the function name TOH is given and has some parameters integer n, a, b, c. In the first line of the function, the if statement is given as the condition states n is greater than or equal to 0. If the condition satisfies, the body of the statement executes. Inside the statement, the function return is given inside the TOH n-1, a, c, b. This is the step 1. As I previously explained, the step 1 states move n-1 disk from A to B using C as auxiliary. In the second line, the print statement gives the move the nth disk from A to C, and in the third line of the condition, move n-1 disks from B to C using A as auxiliary. Here I am giving a video or visual representation of the how Tower of Hanoi works for several disks as 3, 4 and 5. For 3 disks it needs 7, and for 4 disks it needs 15 moves, and for 5 disks it needs 31 for minimum. Here 3 disks and 4 disks are solved by 7 and 15 moves. Then we are going to solve the 5 disk algorithm in minimum possibility moves of 31. And finally, the Tower of Hanoi problem for the 5 disks is completed in the minimum moves of 31 and completed by following the norms which I mentioned before. While the Tower of Hanoi puzzle is simple in concept, at the end, it's a power of tool for understanding recursion and exponential growth. Its applications extends beyond its just puzzles, serving as an essential learning tool for computer science, problem solving, and algorithm design.